Okay, so in today's class we are going to continue what we have studied in our previous class, that was data dictionary. So what we knew about data dictionary, all the components which we used in our DFD, that is data flow diagram, that components as well as all the data about those data which were in our DFD, that were included in the data dictionary. Then now we know that data dictionary contains all the data about DFD. Now how to write that data dictionary? Before that we have to see a particular DFD. We have the DFD for a tic-tac-toe game, and in which we have two levels of our DFD, that is 0 and 1. Okay, so one more thing, 0 level DFD is known as context diagram. Okay, this was missed in last class, that is context diagram. We will see that in context diagram what happens. Suppose this is our 0 level diagram. Okay, that is 0 level. So what happens in this context diagram, that is here in only one circle everything is included. That is, there are some many things which you have to consider. That is, first one is in one circle only, that is in one your particular bubble, this is called bubble, this bubble you will have the name of your software, what your software is going to do. That is basically written in your this DFD. Okay, that is context diagram, 0 level DFD. This is our 0 level DFD. Second thing, this 0 level DFD will never contain more than one bubble. Only one bubble will be there, which will include the whole subject, whole software, what is there in your whole software, that is included in this 0 level diagram DFD. That is your context diagram. Okay, what is this known as? This is known as context diagram. That is your 0 level DFD, level 0 DFD. Okay, this is also known as context diagram. Here what we can see, only one bubble will contain the whole data about your particular DFD, about your particular software. Okay, what your software is going to do, that will be included in that DFD, 0 level DFD, and that particular bubble, only one bubble will be there in your 0 level, that is your context diagram, not more than one bubble. Many people, what they do the mistake of making more than one bubble in the 0 level DFD. Here only your basic idea will be there, what is my software and what it's going to do, that's enough, nothing else. Here we have shown that one, that is only the one DFD, that one bubble that is showing me that this is my tic-tac-toe software. Okay, here what I am seeing, here human player is playing, okay, with this game. So what the main thing is happening, that is the human player is playing one move, that is, this is my entity, as we have already studied in our previous class. You can see the video there. What we have seen, this is my human player, that is my entity, external entity. What it is doing, it is playing the move that is going to my software, that is my tic-tac-toe software. Then what is happening, this particular software, it is displaying that particular move in your board. You are having a board, your game board, as we know that game of tic-tac-toe, what happens there, this kind of thing is there. Okay, so what is happening, when the player is playing a move, that is, it is making a cross or a circle, the tick that is going to the software, and the software, what it is doing, it is displaying that in your board. Then, so this thing is happening, basically what thing is, this thing is happening in your tic-tac-toe software. So here in our basic level DFD, that is our 0 level DFD, we are showing that much thing, that is, this is my software and this is my entity. So this entity is moving, it's playing a move, and the particular software is showing it's displaying the particular move to my board. This is my board which I am seeing here, this is my particular board. Okay, so this is what is happening there in the diagram, context diagram. Then here only one bubble will be there, not more than one bubble, and this basically, this bubble will have the basic function what your software is going to do. Clear? Now in our second diagram, that is my level 1 DFD, what is happening, now we are breaking that DFD into some more function. What is happening now, here we are seeing there are 4 basic functions, that is our 4 particular bubbles are there. Okay, now what is happening, this is our display board, that is this board. What is this one? This is our data storage. Okay, data storage, where we are storing the data in this particular board. This is my board. Okay, so in this board what is happening, you can see how many boxes are there. 9 boxes are there. So 9 kind of input can be there in my tic-tac-toe board. Then here what is happening, displaying the board. First function you can see here, this one, when we have to number our DFT. Always whenever you are making a DFT, you have to number your DFT. How? In the first level there is only one bubble, no more bubbles. So what I have to do, I have to put a 0. This is my only one function, that is my tic-tac-toe software. So I am putting a 0. Since it is my, in every function you will be putting a 0 there. Why? This is your basic DFT. Then every function, whatever you are going to make, you have to put a 0 for your 0 level. Now what you are going to do, here you are making 0.1, 0.2, 3 and 4. These are the main DFTs which are coming out of this 0. That is my basic software, tic-tac-toe software. What it is doing, displaying the board. First thing what is happening, that is it is displaying the board to all the players. That is happening here in my first function. I am seeing a board where nothing is placed, only a back-end board or tic-tac-toe board. Then now what is happening, so how I am getting that board, how I am getting that, displaying that board, how I am getting that one. I am getting that one from this storage. This is my storage, and from storage a function you can see an arrow is going, that is my data is flowing, that is displaying the board. Okay, so what it is doing, it is displaying me the particular board. Then now what happens, here the player is making a move. Here the player is making a move. The data is flowing, that is from the player, it is making a move. What is happening? This particular function will validate the move. That is what kind of validity? See, suppose it is a backend one empty board is there. So if I am putting any sign, suppose cross or circle, if I am putting it in anywhere, I can easily put that one. It is validated. But if suppose here some sign is there, here some sign is there, here some sign. If the player wants to put the sign here, of course this particular function will not validate that one. Why? Since already this is been, it is not empty. It is been placed by something, that is either cross or circle. So it will make it a non-validated one. It is invalid, that one. Okay, the move will be not validated. So this will happen for this particular function. And if the place is empty, then obviously it will validate the move and the player will play that one. So this validity, what it is going to do, this validity will be, the data will be flowing to the board. Here the board is being shown by this display board, and here the validating the move will be given to the board. Then what is my third function? Playing the move. If the particular move is validated, then what will it do? It will play that move. Suppose I am playing for this particular person, I am playing a circle. Okay, then I am validated since it's empty. So it will play my move here. Then, so this is also what it is doing. It's playing the particular move to, it is storing the data to my board. It is playing the data, or it's playing my move to the board. Okay, so again the data is flowing from here to here. Then now what is happening, after this whole thing is going on, the whole thing is done and the whole particular game is completed, then what will happen, a particular winner will be there. Okay, so when the winner will be there, what this board will do, this board will flow that data to this particular function. Here what is written there, check winner. This function will check whether it's the winner is correct or not, whether the move validated by this particular function, it is the winner is correct or not. If it is correct, it will show the result. Okay, it will show the result. Otherwise what it will do, obviously it will again it will show the result, or if the result is not correct, sorry, if the result is not correct, that the winner is not correct, then it will again do the same thing. Okay, same circle will be done. And if the winner is correct that is yes, it's the winner, then it will show you the result. Then so this is what is happening basically in my tic-tac-toe software. Okay, so this is my level 0 and level 1. Now what I have to do, from this software I have to make my data dictionary. How I will make that one? We have the symbols already read in our previous class. So now what we will do, we have to write every particular thing, whatever thing is there in my particular this data. So I have to show that thing here. Okay, so what thing I have to show? First of all, this is my move. Okay, move is what? It is my function. So we know that in basically what happens here, this is my, these particular things are my data flow. So in DFT, the main thing is what? The main thing is data flow. So that thing you have to show. The first one we will see about the move. Okay, so what the move? Move is what? We have to show that what is going to happen in the move. That is, it will be an integer value. Why integer value? Since you can see here 1, 2, 3, 4, 5, 6, 7, 8, 9. So what are these? These are integer values. So I am playing here for my integer values. I am giving the integer values only. So here we will write what? Move. For the move function or the move data, what is flowing here, integer is the value data type which I am using, and comment will be what? Number between 1 and 9. From these 1 to 9 boxes I can place my data in any of the particular box. Then so this is what? This is the first one, that is for the move one. Or here also moves, we are playing for the move, so this move is going to be described here in my data dictionary. First one is done. Now we will go for the further one, that is display. Now what is display? Here you have seen move, done. Now display. What is display? Display is game plus result. This plus we have already studied in our previous class. This was the symbol of comment and this was the symbol of what? Addition or composition. We are going to compose these two things. Add these two things. What thing the display will show? First thing, it will show me the board, that is the whatever move we are going to do, that is our game. Basically what game is going to be there, and last it will show me the result. So result and game are both the things which my particular software is going to show in case of display data flow. Whenever we are playing for the display one, we will be shown this one, the game and result. So second one is also done. We have used this plus symbol also. Now for the third one, that is my board. What my board is, okay. Now game, what is my game showing? Here in case of game, I have used this game. So what my game is showing? Okay, what the game, particular game function is showing what? It is showing me the board, particular this board. That is my data storage. Okay, so this data storage is being shown by this game. In case of game, whole game is shown where? Here in this data storage, that is my board. Okay, so this case we are showing our data storage, whatever thing is being stored in our particular board. Okay, now in case of this fourth one, that is board. Now we have used board. Now what is board? You can see here that everything is going on one by one. First we used move, then display for this one. Now after display, what? Here game. So what is game? We have used game. So game we are showing game, that is board. From where we are getting the game? We are getting the game from the board. Then again board. Now what is board? Board is what? In previous class, again you can see what we have discussed. Iteration function. What was that iteration function? Like this, that is integer value. What integer value I am going to repeat? That is 9 times I am going to repeat that one. I am going to repeat this board 9 times. What board? Why 9 times? After 9 times you are not going to have any empty space. Maybe a game of tic-tac-toe, maybe you can get the winner in 5 attempts, or it maybe the last attempt can be 9 attempts. That will be showing any a draw game which will have no winner. So maximum you can have 9 attempts. So that case, what? Integer value in board game, what we are getting? Integer value, that is 9. The iteration will be for 9. 9 times we are getting a value. That will be an integer value obviously. So 9 times we are going to iterate that one. If you are getting the winner before 9 times, you can get that one. It's okay. But if you are not going to get, maximum you can have at least 9 values. So we can iterate up to 9 values. So we have used a iteration function also that we have seen in our previous class. Then now what? Here we have seen result. Everything is clear now. Move is clear, display is clear, game is there, your game is described, your board is described. Now the last one, that is my result. What is my result? There also we have seen either this or this. Either this or this function we have used in our previous class. You can see the sign. Now what can happen here in this case? What can happen? You are playing with the computer, right? So first suppose you are giving a particular sign, computer is again giving a sign. This all happens in a tic-tac-toe software. So now here there can be 3 possibilities which can be given as a result. What possibilities? First one, computer won. If you lose, then computer can win. Second one, human won. That is, if computer loses, then you can win. And third one is what? A draw game. So these are the basically 3 possibilities which can happen in a tic-tac-toe game. So here what we can see, either this or this one. That function we have already studied in case of data dictionary symbols. So this symbol also we have used. Since it is a written statement, so we are giving this inverted comma sign. So computer won, human won or draw. So basically what you see in this particular data dictionary, what you can see, everything, every DFD, whatever data flowing is going on in your DFD, everything, each and everything you have to describe in your DFD. First take one function from a level 0, go continuing from that one, you are getting again a word, again search that one, give the basic data of that function, again the next one, data storage, everything, data storage, the whatever data flow is going on, your entity, everything should be included in your particular data dictionary. Here also you can see my move is there, my display is there, my particular game board is there, game is there, whatever game is going on, that is there, and my result is also there. Here the result is also there. So everything will be, whatever thing we have used here, each and everything will be included in your data dictionary. You have to see that none of the thing is being skipped. Everything will be in your data dictionary. Why we are making this data dictionary? If anyone from the testing, that is your implementation team, is going to see your data dictionary, then they can easily have the idea, basic idea of what is going to happen in your particular software. So this is what is happening. As we have already discussed, data about data, that is the metadata. Every data about the data is there present in your DFD. That is your data dictionary. So you can see here all the things we have included in basic, this whole structure, the pictorial structure, whatever thing you have made in your DFD, whole diagram, whole thing is being given as the small document, that is your data dictionary. Very small, but everything is maintained there. You are making the whole DFD, but in a basic, in a very short thing, you are making the whole data dictionary and the whole thing is covered there. Right? Now, what we will see, what is the importance of this data dictionary? Why we are using this data dictionary? Everything has some importance. We have some importance here. Let's see now. What is the importance of this DFD, data dictionary? Okay, let's see that one. And we have to also see that, so we have to start a data dictionary whenever you are using, start from the basic function, that is your basic DFD, context diagram. Then you go to above functions, that are your secondary functions which you are using in your level 1, level 2, etc, etc. Okay, so that you will go of just it automatically it will come from first. When you are taking a function, automatically when you are describing the function, you will again get the next function. This is going on until and unless you will be in your ultimate level, the last level. This will automatically come. You will see that automatically you are getting the functions one by one. Then now, what is the importance of this data dictionary? Okay, importance of data dictionary. Okay, now what is the importance of data dictionary? Why we are using this data dictionary. Why? Since we can use here an standard terminology. Okay, terminology. Why? Many people are working in your team. When in your designing team, so many kind of people are working. In your implementation team also some people are working. Some standard terminology should be used. That is, we have seen what kind of symbols we are using. So in every DFD or every data dictionary, this kind of things will be used. So it is basic and it is very much known to everyone. This is your standard terminology. It's not going to change in any way. Whichever company you are going, whichever data dictionary you are going to see, you will see that these terminologies are not going to change. They are always the same. Okay, since this will help us. If these terminologies are changed, then again this company's DFD or this company's data dictionary, you have to see what are the terminologies again in next company. That is not happening. Whichever team, whatever team is getting the data dictionary of any company, they can easily work on that. That is the terminology is mainly standard. They are not changed anytime. Whatever context, whatever symbols, whatever you are using, they are not changing with time. Not with time or not with company. Never changing. They are same always. Why this is happening? Why we do that one? Why we are using a standard terminology? This advantage is what? For every engineer, okay, every engineer can easily understand this. Can easily understand. Okay, these things. They can easily understand. Whatever, wherever, all kinds of, whoever coming to your team, whoever is going from your team, doesn't matter. Your work will be going on. Since everyone is friendly with this kind of symbols. Okay, everyone knows that one. Whoever is working in your designing team, if new people are also coming, they will also know this kind of terminologies or this kind of symbols. They are, since they are standard, so they are not going to change. So whatever your team is going to change, if your team is changing or maybe if anything changes, then that for that particular engineer also, it is not going to be an unknown thing. Okay, they are also knowing the same thing. The work will not stop at any point. This is the main thing what is happening here. Third thing is what? It is containing all the definitions of your DFD. All the definitions of your DFD is being contained here. So if your DFD is, whenever you are anybody is seeing your DFD, they can easily understand your data dictionary. All the details of your DFD, if by pictorial view they are not getting anything, they can easily see your data dictionary and they can easily understand what is going on in your DFD. Maybe pictorial, whatever things you have made, maybe the person is not understanding that one, but when he is seeing your data dictionary, they can easily understand what is going on in your DFD or what thing is going on in your particular software. Okay, so these are the things which are the importance of your DFD. And again what? Since these things are going on for your DFD, all the SRS, whatever things are there in your SRS document, they are also contained here. All the functions in your SRS document are also contained in your particular DFD data dictionary. So you are getting the whole things. That requirement is also there in your particular data dictionary. The designing thing is also there in. So it's the full package. Okay. So this one is having a very important role in your software engineering designing. Done. Now what we will see, what are the errors? What kind of errors can be there? So basically, since when we are making a data dictionary, some errors are there which everyone makes, but you have to take care of those kind of error. Okay, before that we will see what I have told you, one thing, that is my context diagram. We will see the errors afterwards. Okay, context diagram, one thing you have to see there, that is your zero level 0. Okay, zero level DFD, you have to see many things. Suppose we are taking the example here, suppose user is there. Okay, next here RMS mean I am doing for a particular calculator. Okay, RMS calculator. So what is it's doing? The user is giving the data, it is calculating the RMS and it's giving to the user back. So what is happening? Basically this is my calculator which is showing the RMS, so root mean square. So this thing is again shown to the so what is the main thing? This is my software, this is the main function. I cannot give more than things in this particular DFD, context level diagram. That is my level 0. Every time what mistakes everyone makes, that is this kind of thing is having this, they are making what? They are giving more than one bubbles in this particular level 0. This is not happening. Whenever you are going for a level 0, you have to see basically what is there. There only one bubble will be there. That is the whole function of your software, that you have to show with a single bubble, not more than one bubble. Okay, that is what is happening in the context level diagram. That is your 0 level diagram. You have to take care of that one. Second thing, you have to see that whatever thing is going on, okay, that is this data and this data. You have to see the data flow. Every time you have to show the data flow, the arrowheads, where the arrowheads are going. That also you have to see in your context diagram. Okay, now what we have to see, while constructing a DFD, this is what is happening in your context diagram. So these are the basic things which you have to see in your level 0 diagram. That is context. One bubble will be there, not more than one bubble, and the arrowheads, you have to see how the function in a very basic way. You have to show the basic function. That is, my software is going to do this basic function. So very means very smaller way, and very not in a very huge way you have to show. No, very basic thing you have to the main idea you have to give by this context diagram. So with only one bubble. Now let's see what are the errors while making a particular DFD. When you are making a DFD, data flow diagram, basically what are the errors which happens? What are the errors which are mainly done by any people? Okay, first thing is that context diagram contains only one bubble, as I have already shown you. That is, this is my RMS, this is my particular person, that is the user, and this thing. So this thing is happening RMS. So this is the thing what is he is giving the data, and it is returning the RMS. So only one particular bubble will be there. What everyone do, they makes a mistake that they are giving 2-3 bubbles. That no, I am not satisfied with one bubble. Whatever function my software is going to do, that cannot be described in one bubble only. I am going to do 2-3 bubbles. I am going to show 2-3 functions so that I can easily show it more accurately. But no, you have to show your DFD, context diagram DFD, that is level 0, with only one bubble. Basic function, you just show how the basic function is going to, what the user is going to give you, the input, and what output you are going to, basic function, nothing else. Okay, so this is the one error but everyone do. Okay, this one. Then second one is what? External entities, that is my user. These external entities are basically used in this kind of DFD, that is my level 1 DFD, it is level 0 DFD. Whatever entities you are going to use, those entities are basically used in this context diagram only. That is your external entity. External entity, okay, that will be used only in this 0 level, not in other levels. Basically you are using that in your 0 level. Why? There what you are going to show, you are going to show how your DFD is going to, how your software is going to work. So there you need a external entity to show the function of your DFD. So you are using that particular entity in your 0 level, where you are showing the function of your software. Now what? Third one, so in other levels, level 1, 2, how many levels you are going to make, you are not going to show those external entities. Now what? Third one is up to 3 to 7 bubbles. You can make up to 3 to 7 bubbles for a particular bubble. whichever level is there, you can make minimum 3, maximum 7 bubbles for a particular bubble in your DFD. If I am making a DFD, I am making a bubble that is showing my function. Now, when sub-functions you are showing, whatever things are going on, that thing you will also denote with the bubbles. But for a particular bubble, since this is my bubble RMS, what we have seen in the previous one, that is my tic-tac-toe software was there. Tic-tac-toe software was there. This was my bubble. That was my 0 level bubble. I am showing it like that. But from that, what we have seen, we were making 4 bubbles. Validating the move, then displaying the board, displaying the checking the winner, and what was that? Checking the winner and displaying the board and playing the move. Okay, so these things were there. So I was breaking my bubble, particular bubble, into 4 other bubbles, but not more than 7. You can make it up to 7. If you want to make more and more describing nature, you are making it of more describing nature, then you can give up to 7, but not more than 7. Again, what? Not less than 3. Up to 3 you have to make. Up to 3 bubbles, that is, it will be showing up to 3 sub functions will be there, which will be showing the function of your particular bubble. That is your particular function. Okay, this will be my, this tic-tac-toe was my basic function. It was my function. So I was having 4 sub functions. That was validating the move, the displaying the board, playing the move, and showing the winner. Okay, so these were my sub functions. So I can make the I was making it 4 sub functions. You can make it more than that one also. You can describe more. If you want to describe more, you can do that one also. Again, in level 2 also, same thing. Whenever you are taking a particular function, you can make 3 to 7 bubbles, not more than that, in any level, whatever level. We are making, what we are doing, we are first of all, we are having the basic function, that is, it was the basic function, what, tic-tac-toe. Then from that basic function, we were breaking that one. So again, this is also my function. Now in this case, when I will be making level 2 DFD, this will be also my function. From this also, when I will break it, I can break up to 3 to 7. Okay, again next function also you can break like that. Level by level you are going ultimate level. Up to when you are reaching the ultimate level, you will see that every bubble, every function can have up to 3 to 7 sub functions, not more than that. Then, so this also, it also happens when while making an error, this can also happen. Maybe, okay, I am satisfied with 2, I am not going for 3. No, you have to see this one, 3 to 7, you have to maintain that one. That is the basic thing. Now, what happens? Control information. Control info should be there. Okay, control information should be there. What control information should be there? This is my control information. Whatever thing, that is how my data is flowing. Control information means what? Not the whole thing. I will not show. It's not a control flow chart. It's not a flow chart that I am showing the control flow, how the flow is, how the control is being flown in the chart. No, here what? The data control, how my data flow is going on, that thing is shown here. Okay, how my data is flowing. From there, they always see the head of the arrow, you have to see that one. Since it's a data flow diagram, always you have to take care of how the data is flowing. Then, so always take care of the arrows, your arrowheads, how they are going, to which thing they are going, from which entity they are going to which data store, from which data store they are going to which. This thing you have to see. This makes the people makes error on this also, that you are just showing the data flow, but you are not giving the arrow. That is from which to which it's going, it's not shown. So this thing you have to take care of. This is also what happens when you are committing any error in DFD. Okay. Now, one more thing is that is you have to take care always that whenever you are making a particular, suppose whenever you are showing a data store, suppose this is my data store. Okay, any storage. Like in a previous case, what it was a board. Okay, you will see that from a particular bubble, okay, this data store, this can happen. or these can happen. These things can happen from data store to a bubble to a data store. But these things can happen, but a data store to a data store can never happen. Okay, a data storage from a data storage to a data storage, it can never have any kind of data flow. Never have. Since why we are not having that one? This is my function. If I will do any function, in previous case also we have seen that in sometimes when we were playing the move, that was shown in our board. That was our data storage. That is playing the move, the function to the storage. But when the storage was we were showing the display in the board, that was from the storage to the board. But it can never happen that the data cannot flow from a storage to storage. How this will happen? This cannot happen. Since you have to have some function which you will be having the data from a function to a particular storage or a storage to a function. But it can never happen from a data storage to data storage. Some data is going on. This flow can never happen. Okay, so this thing you have to keep in mind, that from a storage to storage, no data, any data can never flow. Then, so this is also a mistake which is being committed while making a DFT. And the last one that we have to see, that is we have always to show data storage to data storage, no data flow. Okay, here no data flow. Then, and last one is what? We have to see all the SRS documents, all the functions that is mentioned in our SRS documents. All the functions mentioned in your SRS document should always be shown in your DFT. Since your DFT is the reflection of what requirements you have in your software, you are getting the requirements from the customer, and from those requirements you are going to make develop the design. So while making the design, okay, the main basic design, you have to keep all the requirements, whatever things your customer has given to you. Then you can make a best and a quality software. Then, so you have to keep in your mind whatever things my customer has given me to implement in my software, those requirements I have always to put in my particular DFT. Then only I will give a good design and which will give a particular accurate software which will be needed by the customer. Then, so these things, these errors, basically what happens, these errors are being made while making a DFT. So always take care while developing a DFT, always you have to take care of these particular points, right? Now what the basic shortcomings of a DFT? What are the shortcomings? Everything is correct. DFT is helping us in a very huge way, but some shortcomings are there which we will discuss now. Okay, what are the shortcomings of this DFT? Functions performed by bubble should be precise and specific. That is, whenever you are making a DFT, like I was making here, human player and the software, tic-tac-toe software. Okay, so what I was seeing there, functions performed by my particular bubble is very precise and specific. Why specific? Here what? My particular software is going to play the game of tic-tac-toe. That's all. That is very precise. It's not huge. It's not very descriptive. No. It is very precise. My software is going to play a tic-tac-toe game. Second thing, very specific. To the point answer. To the point thing you have to show there. Again what we were showing. Validating move or displaying board or what? Playing move or showing the result. So these also you can see, these were our next level, these were the functions, right? So here also you can see the functions are very precise. Validating the move means it is just validating the move, displaying the board, playing move, showing the result. So what is happening there? we can see that what they are doing, basically they are just showing us a specific one, precise and specific one, very precise. This thing, this function is showing me the, displaying me the board, not very descriptive. You can easily understand from the name of your function, you can easily understand what function is going to be done by your particular function, particular bubble. So you have to make it very precise and very specific, not a descriptive one. You are going and writing many things in your bubble. No, very precise. What function is going to be done by your particular bubble? Very precise and very specific, to the point answer. Okay, so this thing is playing move, showing result. Then very specific and very precise. So this is the main thing. This is the advantage also. This is the advantage also, since you are showing a very specific manner, you are showing your DFD. But the shortcoming is there, that is, in that thing you have to show your basic data. You cannot use more words. You cannot express by more words. No. You have to show this thing in a very precise manner, very specific manner. So you have to have that art to make it a very specific manner. Okay. Now next thing, no control aspect is not shown here. Since it's not a flow chart, already I have told you it's not a flow chart. So no control structure is not shown here. You cannot from a DFD, you cannot know what is my control, how the control is going on. No, you will only show the data. Only the data is shown. This will, what the thing is going on. This is showing a, I am doing a move. This is displaying my move. But how this is happening, these things are not shown. The control is not shown here. So you have, it is the shortcoming also. What the thing are going on, that is not shown. Only the basic data flow is shown in your DFD. So this is the shortcoming. You cannot know about more details, you are not knowing there. It is only for a basic idea only, but not for a descriptive manner. For a descriptive thing, you have to follow other charts, or we will study about more charts. But this thing is basically showing you the main structure, main function. Okay, huge description is not been shown here. So this is a shortcoming. Now decomposition has been done. Third one is what? Decomposition. What is decomposition? This was my level 0. Now my level 1. Suppose it is also not sufficient, then you have to again construct level 2, then level 3. So by this what? Until and unless you are able to describe all the functions neatly and accurately, you have to decompose your DFD. This is a huge shortcoming. Since from one particular this DFD you can only know the function, what is happening here. But to describe your DFD, maybe it will take 3 to 4 levels also. To describe your DFD, to describe wholly, you have to go through other levels also. So this is a shortcoming. From one DFD or two DFD, you are not going to give the description of your whole software. Obviously, you need 2, 3. So ultimate level, whenever you are not up, until and unless you are not reaching your ultimate level, you are going on decomposing your DFD level by level. So this is a shortcoming. It is huge time taking also for your designing phase. Since you have to, in rapid action development model, other models, you have to have the project done in a specific time also. So you have to take care of that. So it's a shortcoming. And how to decompose is not shown. You are showing how we are just showing this decomposition, that is my, from this software or this function, I am decomposing this function to this. But how I am decomposing, why I am choosing these sub functions, that I am not showing. It's not a descriptive manner. It is just a basic idea of your DFD. How you are going to decompose, how you are going to show, that is being shown here. But how you are decomposing, the whole data is not provided. So this is also a shortcoming of your DFD. The whole description is not given. It's not a descriptive data. It is only basically a definition of your data. I have already told you, data dictionary is also data about your data, definition about your data, but not description about your data. Okay, so this is the shortcoming. You are not getting the whole description. You are just getting an idea, basic idea you are easily getting from this one. But description you are not getting. How these are decomposing, how these functions are going on, how this data is flowing. These things are not coming. What data is flowing, that you are getting. That thing you are getting from it. But how this data is flowing, you are not getting from there. Then Now all functions you have to show. That is your main shortcoming. This is the advantage also, that from a particular DFD, if you are taking a data dictionary, you are getting all the functions you are getting, or the all functions which you are using in your particular software, everything is being shown in your DFD correctly, level by level. But what is happening, that is also your shortcoming is also there. That is, you have to show all the functions of your particular software. It's very time taking. So as well as for your designing phase, it will be a lengthy process also. So this is also a shortcoming of your DFD. So always remember, while making a DFD, you have to see that you have to start from the context diagram and end until you are reaching the ultimate level. But it is a very you can have a very beneficial way for making this DFD. While you are constructing a data dictionary, you can have a basic idea very nicely and accurately. You can give the idea what your software is going to do, what the functions are included in your software. But also it is time taking, as well as it is a huge and lengthy process. Figure by figure you will have to construct, then you can give a data about your particular software. Then so this was all which was included in data dictionary as well as DFD. Now in next class we will again have some topic related to this designing tools only. Then if you have any kind of queries, you can ask me in your comment section, and if you want to give me any suggestions, anything, then you can write to the comment section. If you like my videos, then please give me a like and kindly subscribe my channel so that I can share more subjects related to our technical education. Thank you and take care.